differentiation in mathematics, differentiation can be defined as a derivative of function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. So list and explain briefly 6 common techniques of differentiation. One is constant rule. So a constant rule is basically if we want to differentiate a constant. So if you need to find the derivative of 6, 7, so it's equals to 0. Second is a power rule. Power rule is if you want to differentiate a variable with a power. So if we need to differentiate x power of 3, then it equates to 3x power of 2. Addition is subtraction is two separate variables separated by plus or minus sign in the middle. So if we want to differentiate here 4x power of 3 plus sin x, it equates to 12x power of 2 plus cos x. Okay, number 5 is product rule. It's basically a multiplication. So we have two variables here, but it counts as one term because it is time between that. So we separate it by using we substitute it by using u and v. So u equals to 4x3, and u prime after we differentiate it is 12x time 2. So the as you can see in the front, so the final answer will be 4x times 4s power of 2 times x cos x plus 3 sine of x. So the final question that we have here is a quotient rule. Quotient rule is basically just as the same as product rule, but is a division. So we take the numerator as u, we take the denominator as v. So as you can see here, so we include the formula, so we put the u and v into the given formula, and we have the answer x power of 2 plus 14x divided by brackets x plus 7.
So this is question 2. Find the dy dx for the following function. Question A, y equals to x power of 3 cotangent 4x minus 5. So for the solution of this question, we use the product rule method. First we state which one is u and which one is v. U is x power 3 and v is cotangent 4x minus 5. And then we differentiate u and v, and it becomes u prime and v prime. And then we use the product rule method. Dy over dx equal to u prime times v plus u times v prime. And then we substitute the u prime and v prime that we calculate above. So the u we substitute, we write 3x squared cotangent 4x minus 5 plus x power 3 times negative 4 cos x squared 4x minus 5. And then we simplify the answer, and the final answer is 3x squared cotangent 4x minus 5 minus 4x power 3 cos x squared 4x minus 5. And then next we move to question B. Question B is y equal to x power 3 minus 5x over 9 plus sine 2x. So for this question, we use the quotient rule method because the question are in equation form. So we state which one is u and which one is v. U is 2x power 3 and v is 9 plus sine 2x. And then we differentiate both u and v, and it becomes u prime and v prime. U prime is 6x squared minus 5 and 2 cos, and v prime is 2 cos 2x. Then we substitute the u prime, v prime and u and v, dy over dx. So we substitute into the quotient rule formula, dy over dx, u prime times v plus u v prime over v squared. So we get the final answer 9 plus sine 2x times 6x squared minus 5 minus 2 times 2x power 3 minus 5x times cos 2x over 9 plus sine 2x
We
squared.
move on to the question 3, which is given exponent to the power of x squared plus 1 plus tangent to y equal to 3 plus y squared multiplied by ln 5 plus 4x. Find dy dx using implicit differentiation. First, what we need to do is we need to differentiate all the expression, and we will get exponent x squared plus 1 multiplied by 2x plus secant square 2y multiplied by 2 dy dx equal to 2y dy dx multiplied by ln 5 plus 4x plus y square multiplied by 4 over 5 plus 4x. Next, we will need to simplify the expression, and it become 2x exponent to the power of x squared plus 1 plus 2 secant square 2y dy dx equal to 2y multiplied by ln 5 plus 4x dy dx plus 4y square over 5 plus 4x. Next, we will to separate the term that have dy dx on the left side and the other ones on the right side, and we will get 2 secant square 2y dy dx minus 2y ln 5 plus 4x dy dx equal to negative 2x exponent power of x square plus 1 plus 4y square over 5 plus 4x. And after that, we need to factorize dy ds on the left side, and we get dy ds multiplied by 2 secant square 2y minus 2y ln 5 plus 4x equal to negative 2x exponent to the power of x square plus 1 plus 4y square over 5 plus 4x. And lastly, we need to express dy ds as a subject, and we will get dy dx equal to negative 2x exponent power of x square plus 1 plus 4y square over 5 plus x, and divide by 2 secant square 2y minus by 2y ln 5 plus 4x. That's all.
For the last question, I am going to explain to you on how to solve question 4 to estimate this question using linear approximation. From the equation, we have to turn the number into variable x, and we proceed and state the x over a value 3.99 as the constant number, and a is 4 as the closer number to 3.99. Okay, firstly, we have to analyze the structure of this question, and we make it into simple form, as we have to move this square root of 3.99 outward, so it will become like this, and we have to differentiate all this structure into this form. Okay, next we have to state two value, x over a 3.99 as the constant number, and the value that is closer to 3.99. So we will moving on to the next stage. So from the first equation, we have to change the x variable into 4, and we change the square root over 3.99 into 4, so it will be negative 15. And for the differentiation, we also have to replace the x variable with 4, and we get the minus 65 over 8. So next we have to insert all this value into this formula, and we get the final answer by negative 14.1.